Good afternoon. It's Wednesday, September 30th. This video is in regards to the SEED project and introducing you to a strategy we'll use throughout the year called I-squared. So let me share my screen. So if I go back to Google Classroom, I'm looking at the week of September 28th, and I'm looking at the assignment that's going to be due on Sunday about our seed germination project. You'll be creating two products. You'll be creating a graph with a caption. That's the I-squared strategy, which we're going to do right now. And I'll be making a second video where you will create a scientific explanation using this CER tool. Those are the two things you'll be submitting on Sunday for the SEED project. The gallery walk is not something that we will deal with till after this Sunday. So nothing to do for the gallery walk. So let's take a look at the I-squared strategy slides. So if I go over and open up my tab, there we go. And so you can see I-squared because it stands for two words that begin with I, identify and interpret strategy. And this is a process that we will go through in small steps, but eventually we hope you can do without having to go through the steps. So we're going to start out by doing three steps. We're going to do an identify step, we're going to do an interpret step, and we're going to do a caption. So step one is the identify stage. It's also what we call the what I see. Or we call it WIS for short, W-I-S, what I see. So what you're going to do is identify any changes, trends, or differences. You're going to draw arrows and write a WIS comment for each arrow. You want to be concise, just what you observed. Do not try to explain at this stage. A lot of people have a hard time at first because they want to explain at this stage. We just want to point out what we see. So let's do a sample. Here's a sample graph. If I look at the title and the axes, I can sort of figure out what it's about. This is a average monthly temperature in one U.S. city. I can see the x-axis is the month going from January to December, and the y-axis is temperature in Celsius going from 0 to 35. And so the question is, what do you see? And you want to sort of break the graph into sections, not the whole graph overall, but in sections. So what's something you see on this graph? So one thing that I see is it has an upward slope between February and July. The graph goes up from February to July. I don't explain it. I don't try to make any sense out of it. Right now, I'm just stating what I literally see. I literally see the graph is going up from February to July. So it's another thing you see. Potentially, maybe you saw that there's a peak in July. The highest point in the graph is in July. Another fairly obvious thing you might see is there's a downward slope. The graph goes down between July and December. So notice I'm breaking the graph into pieces and I'm observing what I see in each section of the graph. So the front half of the graph, I'm seeing an increase, a rise. At the top of the graph, I recognize that as a peak. And then on the other side of the peak, I see the graph going back down. So typically you want to identify 3 or 4 key features about the graph, and you literally want to write a box or a note on the graph. Then we move to stage 2, which is the interpret stage. What it means, we call it the WIM statement. So WIS and WIM. WIS, W-I-S, what I see, and then you do the WIM, what it means. So you're going to interpret the meaning of each WIS statement with a WIM comment. They connect. Do not try to interpret the whole graph, just each section. So here's our initial comments. Usually it's a good idea to go back in with a different color note, different color marker, and try to attach a WIM to each WIS. So our first WIS is what I see. I see an upward slope between February and July. So what does this mean that the graph is going up between February and July? Right, it means the temperature is increasing. The temperature increases from about 7 degrees Celsius in February to about 30 degrees Celsius in July. And so I add another box that explains what that upward slope means. The average temperature in the city increases between February and July. The peak, what does that mean? The peak, that's the hottest month of the year. The hottest it gets in this particular city is it gets around 29, 28 degrees Celsius. In July is the average temperature. So I add a WIM box. The hottest average temperature in the city happens in July. The city must be, and I could also then deduce from that possibly the city must be in the northern hemisphere. If my hottest month is July, that must be when North America is tilted towards the sun. And then, of course, the third box we can interpret that this is a point when the temperature decreases in this city. We're seeing a decline in the city. It goes from about 28, 29 degrees Celsius down to nearly 5 degrees Celsius in December. So this is the whiz and whim. The blue boxes represent the whiz, what I see. The green boxes represent the whim, the what it means. So now we're going to use those to put together our caption. That's our goal. Our ultimate goal is to put a caption. Every graph should have a caption which explains what the graph is displaying. You're not giving opinion at this point. You're not making any claims at this point. You're just simply stating what you see in the graph in terms of data. So we're going to the caption. You're going to write a caption for the graph. You're going to start with a topic sentence that describes what the graph shows. So in this particular case, this graph shows the average temperature per month in the US city. Then you will join together each whiz and whim statement to make a sentence and ultimately build that into a coherent paragraph from these sentences. So if we take these together, I can start out with a beginning sentence, a topic sentence. The average monthly temperature in a US city changes over a year. In the beginning of the year, from January through February, we see an upward slope in the graph, which indicates that the average temperature is increasing between February and July, going from approximately 7 degrees to about 29 degrees Celsius. The temperature peaks in July at around 28, 29 degrees Celsius. And then after July, we see that there's an average decrease in temperature between July and December, dropping back down to approximately 6 degrees Celsius in December. And so basically you can see what I just did. This graph shows the average temperature in the city over a year. And then you can see how we put these together. Look at this first sentence. There's an upward slope from February to July. That's the whim, showing there is an increase in the average temperature during these months. That's the whim. So the first part of the sentence is the whiz. The second part of the sentence is the whim. I'm just tying my sentences together. Then there's a downward slope from July to December, which means the average temperature decreases, which is what we're saying here. And then finally, we went back here. Here's my third statement. There's a peak in July, yada, yada, yada. So by making our whiz and whim statements, we make it very simple then to make our caption. And this is the caption that I would publish down below the graph. It gives a summary of what the information is in this particular graph. So that's the I-square strategy, not overly complex. You can apply it to graphs. You can apply it to images, diagrams. There's lots of different ways you can use it. So we're going to ask you to apply this to your particular graph. So let me go over to a sample set of data. You are going to use your plant seed data to create a graph. Now I've got in front of me a graph and data table that I created on a spreadsheet. If you are familiar with doing data on a spreadsheet and making graphs on a spreadsheet, you may do so. Or you can simply use a sheet of graph paper and create the graph by hand. That's perfectly fine as well. Just remember, if you make the graph by hand, you want to include the axes names and units of measurement for the X and Y axis. You want to give the graph a title. All those things need to be there, and it needs to be a neat copy. If you're looking for graph paper, you don't have graph paper at home, just go to Google, search graph paper, blank graph paper, and you can print off a sheet of graph paper, no problem. So there's two ways you can make the graph. Two ways you can make the graph for this project. One, you could take the data for all the days. And so in this particular case, I took I used my research question was, how does the salinity of the water affect the number of seeds germinating, number of black seeds germinating? And I used a small scoop to add salt to the water, and then that salty water was added to the seeds, and that was recorded over 4 days. And I calculated the approximate percentage of salt in the water for each setup. So I had a control group that had 0% salt. I then had one that got a half a scoop, which equaled about a 0.75% salt. One that got a full scoop, which reached about 1.5% salt, and one that got 2 scoops, which reached about 3% salt. And so I took the means, I took the averages for each day. I took the averages for each day. That's why you don't see the bag A, B, and C. I took the averages for each day, and I put them in a data table, and I made the graph. Now, I'm not going to teach you how to make the graph today on Excel. You can do it by hand if you don't know how. And so this is one way to do it. I can do graph all 4 days. Day 0 is the day you set it up, which is 0. Obviously, everybody's day 0 is 0 seeds germinated because they hadn't germinated yet. And I can compare the graph. So I could clearly see in this case, the blue treatment had a steady rate of germination, which was no salt. I can see the half a scoop followed a similar pattern, but only about half the growth. I can see 1 scoop just barely grew, and I can see green scoops are not even represented, that 2 scoops didn't allow the seeds to germinate at all. So that's one way. Graph all your days, make a different colored bar for each treatment for each day. Or it might be better, and you can make the choice, it might be better just to look at the final day. In this case, I could use either graph. Some cases, one graph's going to be better than the other. So at the final day, all I did was take the last day's data, the mean, I took the mean. And on the last day, between all 3 bags, there was an average of 15 seeds per bag. All 45 seeds had germinated. I only had 8 seeds between the 3 bags, an average of 8 seeds between the 3 bags for half a scoop, an average of 1 seed per bag for 1 scoop, and no seeds ever germinated in the 2 scoops. And so I have a single bar. In this case, I then list the treatments down below. Either style graph would work. Bar graph is what you want to make in this particular case because each group was distinct and separate. We're not doing a line graph because it's not a continuous set of data.
Aaron, still in the building. Can you come down to the main office, please? Aaron, to the main office. Thank you.
Okay. So either type of graph is fine. You're going to make it. And then you're going to apply the I-square strategy to it. So say I want to use this graph right here. All I got to do is highlight it. I can copy it, and I can take it over to a Google Doc. So let me go over here and open up a Google Doc. And I can paste it into the Google Doc. Hopefully in a moment. There we go. And now I can apply my I-squared strategy. I can just print this off and do it by hand and take a picture of it. Or if I want, I can do this using computer techniques. I can just make little text boxes. So I can go insert. On the image, it may not let me do that. Anyway, you can either insert around it or you can do this by hand. So I might start putting observations on here. Let me see if it'll let me make a. I could also do it. I just use comments there. It's another way that I could do this as well. So I can make an observation. So what's one thing I see? The no salt, or let me make it even simpler. 0% salt produced the tallest bar. That would be one thing I could add. I could then add another comment. So I want to do at least 3 of these. I should probably identify these as the whiz. 3% produce no bar. You want to find 3 or 4 things you can notice. And maybe my third observation is going to be that 0.75% and 1.5% produced bars shorter than 0%, but taller than 3%. So again, I'm just, what do I see? And again, let me identify that as a whim statement. All right, so this is one way you can do it. Again, you can print it off, you can write it in by hand. Oh, it's not a whim statement, that should be a whiz statement. So let me just change that. So that's my whiz statement. Let me go over here, also do whiz. Okay. And then I would come back and I would try to add to this a whim statement. I can either come back in and just edit it and come down, and now I'm going to add the whim. And so the whim, what does it mean that the 0% produced the tallest bar? This means 0% salt. Sorry, 0% salt resulted in the largest number of seeds germinated. That's what that means to me. And come down here. I can, again, edit this or add a comment to it. So I'm going to go down for the whim. What does it mean that it produced no bar? It means no seeds germinated. No seeds germinated, 3% salt. Prevented seed germination. Hopefully that's making sense. And then when I'm done, I'm going to go put this and I'm going to start stringing this into a caption. All right, so I'm going to write my caption down below. So first make your topic statement. So this graph represents the effects of salinity on the germination of black bean seeds. Now put together your whiz and whim statement. The black bean seeds exposed to water with 0% salinity produced the largest number of seeds germinating. An average of 15 per bag. On the other hand, the black bean seeds exposed to 3% salt water salinity resulted in no seed germination. This level of salinity prevented the seeds from growing. And then I would come back and add my third statement in to wrap this up. right? And so then you have a product you can submit. This you can now submit through Google Classroom under assignment ED6, and you have your graph and you have your caption, right? So I'm hoping this makes sense to you. You certainly can email if you have questions. Again, you may also do the graph by hand, and you may directly write your whiz and whim statements on your graph by hand. You may also write your caption by hand. If you choose to do those things, please take good photos and upload the photos along with your assignment. Okay, I think that's good for I². Again, you'll use it many times throughout the year. Thank you for your attention.